Okay, good morning. Welcome to
FamilyMath number 295.
FamilyMath295. So following our counting project yesterday, you guys noticed a connection between counting and binary. And the problem we were looking at is you had 6 tourists and 2 guides. And the question was about how many different ways could the guides take the tourists. Yeah. In the specific question, there was a restriction that at least 1 tourist had to go with each guide. Today we'll get rid of that restriction. Okay, so just how many ways can the 6 tourists arrange themselves with the guides? Yeah. And we found that there was a way we could look at it from the guide's perspective, yep, and the way we could look at it from the tourist perspective. And I want to extend this and talk about Pascal's triangle, counting, and binary. Okay?
Alright.
Alright, so let's start with Pascal's triangle. How does that go?
Well, 1.
Do you want to take the marker? Can you write it sideways?
Sort of. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1.
Maybe I should write it.
Yeah, why don't you write the next couple rows?
Let's see, 1, 4, 6, 1, 1, 5, 10, 10, 5, 1.
And one more.
1, 6, 15, 20, 15, 6, 1.
Okay, awesome. So let's take a look at our penguins with the guides. Okay. So how many ways can 0 penguins arrange themselves with the 2 guides?
Well, just
in one way.
How is that?
Just
this arrangement.
Yep.
There's nothing to do. And that happens to match
This.
there. How many ways can 1 penguin arrange itself with the 2 guides?
Well, it can go either with the red guide or the yellow guide.
Okay, so how many ways is that?
2.
And does that split out in any interesting way?
1, 1.
1 and 1. 1 way with the red guy, 1 way with the yellow guy. How many ways can 2 penguins arrange themselves with the guides?
Well, let's see.
Well, both could go with 1. They could split up evenly.
Or both could go
with the other.
Okay.
So that's
4 ways.
And
I only saw 3 ways.
Well, so both could go here.
Okay.
Both could go here. 1 could go like this. And 1 could go like this.
Ah, interesting. So we have an interesting combination of order mattering and order not mattering here. Okay. When they both go there, does the order of the penguins matter?
no.
No, because it's the same situation.
Okay. But when they split apart, this is not the same situation.
What's that? Because they're picking different people.
Because they're picking different people. Okay. So how many ways were there to go both with the red?
Well, 4, and that's what's
Well, there's just one way to go.
Both of them go with the red. How many ways are there for that?
just 1.
Just 1. How many ways were them to split apart?
Well,
2.
2 ways, because you can split apart like that or like that.
2.
And then
And how many ways were there to go with the yellow?
Just 1.
Interesting. Let's see if we can figure it out with 3 penguins. What happens?
Well,
Well, you have these situations, you have this situation.
then you have the situation where 2 go over here.
And then there's 3 of those situations. And then you can just flip this, you can also just flip the guides.
And then that'll.
So that gives you the other 3.
So and then there was the other 1 way for that to happen.
Okay.
Oh, they overlooked that one. So 1, 3, 3, 1.
1. So that's fascinating.
Seems like it matches Pascal's
So
triangle.
it seems like we have a connection between Pascal's triangle and the ways penguins can be arranged with Lego guys.
Oh, I
Do you
remember.
think there's something special about the penguins?
No.
Something special about the Lego guys?
Probably not.
So there must be some connection with Pascal's triangle.
I remember from yesterday that we had, if we ignored the restriction, we would have this row.
That's right. we ignore the restriction with the full 6 penguins, we would have that row.
Because we ignored the 2 end ones.
But Pascal's triangle has a really special rule for how it's generated. How is it generated?
Well, it's the number on this number is the sum of the 2 numbers above it.
And the numbers on the outside are always 1.
So that's really interesting. So why don't we explore, see if we can find that connection, how to sum up the arrangements to get new arrangements. So like the 3 and the 3 should combine to make a 6.
Yeah.
And so maybe we can find how that works. Okay? And maybe instead of using the penguins, we'll use the
Snap cubes.
snap cubes. Okay?
Yeah.
Alright.
All right, let's see if we can do that, and then that'll help explain the connection.
Okay.